rotations. Rotations is actually exactly what it means, just like reflections were, right? Rotation is something that is actually really rotating, just like tires, right, on a car. They rotate. And when they rotate, they usually go 360 degrees if they do a whole rotation, right? Now, if you look at these two triangles, we can take the triangle and we can move it clockwise, right? So if you think about a hand, right, on a clock, it can move clockwise, which is always to the right. So you take the hand and you move clockwise, or you can go the other way, right? The opposite way the hand moves, which is counterclockwise, which will be to the left, right? So if we move the triangle counterclockwise, it's going to go this way. And if it's going to go clockwise, it's going to go this way, right? That is very important thing to know. The other one is we need to discuss a little bit about degrees of rotations. We have 4 main degrees that we usually rotate. We can go a 90-degree rotation. 90 degree is literally creating a 90-degree angle, which is like this, right? Creating 90 degrees. So you go, bam, 90-degree rotation is from here up, right? That's 90. Then we can do one more. If we go from here to there is 90, right? And remember that little red square that you see, that little thing, gives us 90-degree sample. So from here to there is 90. If I do one more, from here to there, it will be 180-degree rotation, right? Because now we're creating a straight line. All the way from here to there, that's 180. If I go down one more 90, from the beginning, 90, 180, and I go down, that is 270 degrees. And if I go back up, I will land back on a 0, which is also my 360 degrees, right? So the whole circle around is 360 degrees. Now let's see how many rotations we usually do. If we do one rotation, 1/4 of a rotation, that is our 90 degrees. And if I do 2 rotations, which is the 2/4, right? It's a half of a circle. So we go 90 and one more. That is our straight line, which is 180 degrees. Half of a circle, right? You've heard somebody doing 180-degree turn. They go from here to there, right? 180. Then we can go 270 degrees, which is our 3 rotations, right? 3/4 of a circle. Or we can do the whole circle, which will be 4 rotations, and 4 rotation takes us back to 0, right? Or 360 degrees. Now let's see what's going to happen if I have a shape and I have to move the shape around. So if you read the question, it says, rotate the trapezoid A, B, and C 180 degrees about the origin. The origin is right in the middle, right in the center of the coordinate plane. So what do you have? I'm doing a little magic trick in here. We have our trapezoid and we want to move it 180 degrees about the origin. So I would like for you to imagine that I am the origin and I'm holding this trapezoid. And I want to move it 180 degrees, right? And it doesn't matter if I go clock or counterclockwise because 180 degrees is 2 rotations. I can go from here, if I hold it, if this is the origin, I can go up, which is going to be 90, right? 1 rotation. And then I go one more, which is going to give me 280-degree rotation, right? Now I know which way is the trapezoid supposed to be facing. I could also go from here down 90 and up 180. And if you look, it's going to be facing the same direction, right? 180 degrees, it goes this way or that way, it's the same thing. The best way to do it when you are rotating, guys, is actually grabbing your coordinate plane, your coordinate grid, and rotating it, literally taking it and moving the whole piece of paper. Yes, you will see it upside down, right? Which is actually a good thing. Now you see how it's supposed to be facing, which way it's supposed to be. And after you rotate it, that's when you're going to give yourself those coordinates. So after we rotated it 180 degrees, I basically took the whole piece of paper, right, the sheet, and moved it 180 degrees, which was 2 rotations. Then I'm going to start giving myself my new coordinates. So the A prime was 4 and negative 1. B prime, 1 and negative 1. C prime, remember you have to always start on the x-axis first, right? C prime is 2 and negative 4. And then we have our last point, which is our D prime. And if you count it right, you will have 4 on x-axis. And then we went down 4 units, which is a negative 4. And those are the coordinates if we rotate this image, this trapezoid, 180 degrees, which is 2 rotations, about the origin. However, we don't always have to turn about the origin. Sometimes we're going to be given a shape, in this case, our trapezoid. And the question is going to say, rotate this trapezoid 180 degrees about a point. All right? In this case, our point is the point B. If I am rotating something about a point, let's say the point B, I'm going to look at a straight line and another straight line. And I know 180 degrees is 2 rotations. This point is not moving, right? So if I did 90 degrees, right, I will get literally 90 degrees between these 2 lines, right? This line was straight in here, and to make it 90, I will move it up. Now, that is 90. Now I want to have 180. That means move it one more time, not moving this point. That is going to be now this point, which originally was my point A. So we went 90, 180. This point is not moving, right? So we moved the point A. So the point A prime is now over here. Then you're going to look, right? A prime has certain amount of units, right, in here to go to the next point. And that point is also moving along with the point A prime. This is the way it's going to be facing, right? So we're going to count how many units those 2 points are from away from each other. And the point A prime and D prime were actually 3 units away. So we make sure we make them 3 units away. Then you're going to count, right, how many units away is C prime from D prime. And that was 2 units, right? So we did that. And that's the last thing. We'll just connect the C prime to our now B prime. So point B, it did not move. It's still standing where it was. So point B is B as well as B prime, right? At the same place. After we rotate it, we're going to provide the new coordinates. All right? So we're going to start with our A prime. Always, when you provide new coordinates, make sure you start counting on the x-axis, right? Because that is the first one. First comes x, and then there is y. And then you're also going to give yourself points for B prime, which is also our point B, right? Then C prime, and then a point D prime. So let's start. A prime is 2 units on x, and then 1 unit up. Point B prime is where it was originally, right? That point did not move. So B prime is -1 and 1. Point C prime, after it got rotated, is now -2 unit on the x-axis, right? That's what it corresponds to. And I'm sorry, C prime is actually on a 0, right, on the x-axis. I didn't look correctly. It did not go left or right. D prime on the x-axis is 2, and then we went 2 units down, and that is negative 2. And those are the new points after we rotated them. Points A prime, B prime, C prime, and D prime. And we are done with rotations.